Our first question says that in a shipment of 20 computers, 3 are defective. 3 computers are randomly selected and tested. What is the probability that all the 3 are defective if the first and the second ones are not replaced after being tested? The first step in solving this question is for us to extract out the details that was given to us. So it was mentioned that we have a total of 20 computers. So we have a total of 20 computers, and 3 of them are actually defective. So the number of defective ND is actually equals to 3 of them. Our question now says that 3 computers are randomly selected and tested. What is the probability that all the 3 are going to be defective? So that means we're going to be having the first pick, the second pick, and the third pick. So at our first pick, we can have this right here. At our first pick, the total number of computers that we have it to be equals to 20, and the number of defective computers that we have that to be equals to 3. So the probability of picking a defective computer at the first pick is going to be equals to 3 divided by 20. So that's our first pick. At our second pick, the total number of balls has reduced from 20 down to 19. So we have the total number of balls right here. It has reduced from 20, it has gone down to 19, and the number of defective computers has actually reduced from 3 down to 2. So that means probability of picking a defective computer at the second pick is going to be equals to 2 divided by 19. So let's take this a bit towards the left. Now for our third pick, the total number of computers has actually gone from 19 down to 18, and the number of defective computers has actually gone from 2 down to 1. So the probability of picking a defective computer from the third pick, that's equals to 1 divided by 18. So at the third pick, the probability of picking a defective computer is actually going to be equals to 1 over 18. So let us answer the question that says, what is the probability that all the 3 are actually defective? The probability of picking 3 defective computers is actually going to be written as probability of picking a defective computer at the first pick, and that is going to be 3 divided by 20 times probability of picking a defective computer at the second pick. Given that we've already picked a defective computer at the first pick, we have that to be equals to 2 over 19 times probability of picking a defective computer at the third pick, and we have that to be equals to 1 divided by 18. When we do the math with our calculator, we have our answer to be equals to 1 divided by 1040, and if we convert this answer of ours to decimal, we have our answer to be equals to 0.00088. So the probability of picking 3 defective computers is actually going to be equals to 0.00088. So let's try to solve our second question so we can just take this up a bit. Alright, so the second question says that on a maths test, 5 out of 20 students got an A. If 3 students are chosen at random without replacement, what is the probability that all 3 got an A on the test? So for our second question, this is number 2 right here. So the total number of students we have is actually equals to 20 of them. For our total, we have that to be equals to 20. The number of students that actually have A's, there are actually 5 of them. So that means the number of students that have A's, we have that to be equals to 5. We are going to be selecting 3 students at random. So that simply implies that we actually have 3 picks relative to this experiment of ours. At our first pick, probability of picking an A student is going to be equal to the number of A students that we have divided by the total number of students. And as you can see, we have 5 A students and we have a total of 20 students. So that simply implies that the probability of picking an A student at our first pick is going to be equals to 5 divided by 20. And let's go to the second pick. So for our second pick, the total number of students has reduced from 20 down to 19, and the number of A students that we have has actually gone from 5 down to 4. So that means the probability of picking an A student at the second pick is going to be equals to 4 divided by 19. So let's take this towards the left a bit. At the third pick, all right, so this is at the third pick, the total number of students rather has actually reduced from 19, it has gone down to 18, and the number of A students has actually gone from 4 down to 3 of them. All right, so let's take this up a bit. All right, so that means that the probability of picking an A student at the third pick is going to be equals to 3 divided by 18. So we have our values right here. We have the first pick, we have the second pick, and then we have for the third pick. So probability of getting 3 A student, that is A, and A, is going to be equals to 5 divided by 20 times 4 divided by 19 times 3 divided by 18. So when we use our calculator to do the math, we have our answer to be equals to 1 divided by 114. And when we convert this answer to decimal, we have our answer to be approximately equals to 0.0088. So the probability of picking 3 A students is going to be equals to 0.0088. If you learned something new, I would really appreciate if you can give this video a thumbs up and also subscribe to this YouTube channel and check out my other videos. Thanks for making it to the end of this video, and we'll see you in the next one. Bye for now.